In this problem number 7, for a given material, Young's modulus is 110 giga Newton per meter square. We can call it as gigapascal. And shear modulus is 42 gigapascal or Newton per meter square. Find the bulk modulus K. Young's modulus is E. Shear modulus is G. And find out the bulk modulus K. And lateral contraction, that is change in length in lateral. We need to find out for the rounded bar of it is circular bar of 37.5 mm diameter. So we have the diameter of 37.5 mm, that is in diameter. We can denote as like this, right, pi. And the length of the bar is 2.4 meter. When you apply the load, it will stretch up to this dotted stretch up to. We can stretch up to this after stretching. Due to stretching, it will goes up to 2.5. That is the stretching length. 2.5 mm. So totally you will get 2.9. This is 2.4 plus this 2.5 mm. This is in meter, right? So we need to find out the bulk modulus. So the given data are E equal to 110 giga Newton per meter square. Shear modulus G will be 42 giga Newton per meter square. So diameter of the bar will be 37.5 mm. We can write it as 0.0375 meter. So length of the bar L will be 2.4 meter. Extension, that is while applying the load, the bar will get elongate with the length of delta L equal to 2.5 mm or else 0.025 meter. So to find what we need to find is bulk modulus. Bulk modulus K only we need to find. We know the relationship between the Young's modulus, bulk modulus and shear modulus. We need to find E equal to 2G1 plus, what is this? Poisson ratio, mu, right? So Poisson ratio we can also write it as 1 by m. Some cases they will give Poisson ratio as, they will give m value, m equal to some 4. We need to find out mu equal to 1 by 4. Like that only we need to find out the m Poisson ratio. So we can also write this as in terms of 2g1 plus 1 by m. Right? So we have, what are the values we have? We have the E value, G value. So we need to find out the Poisson ratios value. Let us substitute all the value. E equal to 110 10 to the power giga means 10 to the power of 9 is equal to 2 times of 42 into 10 to the power of 9 plus 1 plus mu we need to find. Poisson ratio only we need to find out from this. So we cancel this terms, common terms, and if you solve this, we will get Poisson ratio equal to, so we will get 1 plus mu, we keep these terms here, and equal to, we will put 110 divided by, this is 84. If you do the calculation, 110 divided by 84, so we are getting 1.3, and 1 plus mu equal to 1.309. Mu will be 1.3049 minus, this is 9 minus 1, we will get 0.309 as a Poisson ratio. I told already the Poisson ratio for the system will be 0.2 to maximum it will be 0.2 to 0.5. So we identify the value of Poisson ratio. And we know the relation between the bulk modulus K equal to we can write it as in terms of K, mu and E, we can write it as K equal to M, or we can call this as we can write Poisson ratio in terms of 1 by M equal to 0.39, or we can write as a M equal to 1 by 0.3, you will get 3.22. We have the K equal to M E divided by 3 M minus 2, right? So if you apply all this value, M we know, K we know, 3 times of M and V 2 we know. What is this? M equal to M we know, when M value is 3.22, Young's modulus you know 110 gigapascal, whole divided by 3 into M we know 3.22 minus 2. So if you solve this, 3.22 into 110 is equal to divided by 3.22 minus 2. So we have 9.6 into 10 to the power of 9. This we keep as it is, 9.6.77 10 to the power of 9 Newton per mm square. This is gigapascal, 96.77 giga Newton per meter square. We can write it as Pascal or gigapascal. You kindly note out the units. So second we need to find out this. We find out the bulk modulus. K value is bulk modulus. Second we need to find out the bulk modulus. Second we need to find out the lateral contraction. Lateral or delta D we can contest. So lateral strain first we need to find out. Lateral stress and lateral stress. So what is it? Lateral contraction. We need to find out the delta D. So from that we need to calculate the change in length and original length, right? So let us go for longitudinal strain. Longitudinal strain, that is change in length by original length. So 0.0025 is the change in length divided by original 2.4. We will get the lateral strain 0.00104 if you do the mental calculation. And lateral strain will be, what is the lateral strain? So longitudinal strain into Poisson ratio. You know what is the Poisson ratio? Poisson ratio, from the Poisson ratio we will get the, what is Poisson ratio? Poisson ratio, let us write here. Let us write mu equal to longitudinal strain by lateral strain. From this only we can identify what is lateral strain. So it is longitudinal strain into mu. We know that is a Poisson ratio. So we have the value 0.00104 into Poisson ratio we written as mu. So 0.00104 into 1 by 322. So we get lateral strain equal to 0.000320. So lateral, from the lateral strain only you will get the lateral contraction. So lateral contraction, how much it reduced in lateral contraction? So lateral contraction is equal to, so from the diameter only we can change that. So lateral strain into lateral distance, length. So this strain equal to change in length by, so change in length, what is the change in length? Delta D, that is lateral contraction into original diameter. So if you multiply with this 2, we will get this value. So 0.000323 into D, if you multiply you will get this value. So what is the diameter we have? Diameter is equal to 0.03323. Diameter is, we know the value of 37.5 mm. So we will have 0.0121 mm is our lateral contraction. So we have to use the lateral contraction, means lateral diameter you have to use, not the total length. So in this problem we have find out the bulk modulus and lateral contraction of the problem. So for that we solved for the given material, Young's modulus is 110 gigapascal, shear modulus is 42 gigapascal. Find out the bulk modulus K and lateral contraction of the rod. They have the 37 mm diameter with 2.4 mm length with the stretching of 2.5 mm. So we have the diagram given data as bulk modulus. We know the form in terms of Poisson ratio we have to write. Poisson ratio we have mu, or we can call that as 1 by m. Some cases they will give m value directly, so we will substitute that. From that we find out that the Poisson ratio is 0.309 or 1 by m equal to 1 by m equal to 0.309. So we have the m value 3.22. So okay, this is the formula in terms of m. You can also find out the k in terms of mu, right? Check, we can replacing that mu, m will change. So if you find, you have the homework for that. And we have find out the bulk modulus 96.77 gigapascal. Lateral contraction, we have to find out the lateral strain. From the lateral strain, longitudinal strain only we will get the lateral strain. For the lateral strain only we will get the lateral contraction, right? Here only we are using Poisson ratio or 1 by m. So the lateral contraction is delta D equal to 0.012 mm. Thank you.